Hello again. Now we're going to talk about solving systems of linear equations using the elimination method. And when we talk about the elimination method, there's one really crucial step we need to keep in mind. These equations must be organized. So by that, I mean we need our x's above each other and our y values above each other and our constants organized. So we want everything lined up. And this builds us towards a matrix thought process for solving systems of equations. So organization is key. Then the next step is a choice. We have to choose a set of variables to eliminate. So you'll notice we have x's and we have y values, and these equations are not organized. We choose either to eliminate x or eliminate y. When we do that, we are going to multiply by some scalar. A scalar is a multiple, so we're going to multiply by a scalar so that we have opposite coefficients. All right, so we're going to choose a set of variables to cancel. And then we want opposite coefficients. Once we have done those two steps, it's as simple as just adding the two equations together. This creates one new equation with only one variable. And then the steps are, as we did in the previous video with our substitution method, we're going to solve for that one variable we have. And then we'll plug that variable into one of the two equations to determine the other missing variable, finally writing our solution as an ordered pair. So step one, the first thing we need to do is we need to organize these two equations. So my first equation, I've got x minus 3y equals 2. My second equation needs to be rearranged similarly. So that is 6x. 6x is directly below it, but you'll notice the 5y needs to come over to this side. So I've got plus 5y, and that's equal, this 34 is going to move to the other side of the equation. I have negative 34. So step one is very important for using the elimination method. So now we have to make a choice, and there are infinite correct choices. When you're working this problem, you want to choose the path of least resistance. So again, you'll notice here, I have a variable with a coefficient of 1. That's very easy for me to manipulate. Remember, I said I want opposite coefficients. So what number would be opposite positive 6? Negative 6. So if I multiply this by negative 6, I will have a negative 6 there. Now that's not the only choice. I could have said, let's make these guys opposite coefficients. In that case, the least common multiple between negative 3 and 5 is going to be 15. So maybe multiply the top equation by positive 5 and the bottom equation by 3. And so you'll see if I do this, I end up with 5x minus 15y equals 10. And down here I have 18x plus 15y equals negative 102. So you should see here we have opposite coefficients. So when I add these together, those y's are going to cancel. That is not how I'm going to choose to do this problem, though. I'm going to do it the first way I talked about. So going back and again, thinking about our choice, my path of least resistance is multiplying only one equation. And I'm going to choose to multiply this top equation by negative 6 because then my x's will have opposite coefficients. So what does that change this top equation to? I have negative 6x plus 18y equals negative 12. My bottom equation will remain the same, so I'll just rewrite that. 6x plus 5y equals negative 34. Once we have those opposite coefficients that we've created using a scalar multiple of our choice, we're going to add the two equations together. This will create one new equation with only one variable. So adding these together, negative 6x plus 6x, that gives me 0x. You'll see that's going to cancel. 18 plus 5, I have plus 23y, and negative 12 plus negative 34 gives me negative 46. So essentially what I have here is that 23y equals negative 46. This, of course, is very easy to solve for y. I'll divide by 23 on both sides, and I end up with y equals negative 2. Y equals negative 2. Cool. So now we just need our x value. I can take this y equals negative 2 and plug it into either of these two equations. All right, so we solved the equation, we got a value. We're going to plug that solution into either or both of the original equations and find the other missing variable, which would of course be x. Once we have that x, again, we'll write that as an ordered pair. So I'm going to come over here. I'm going to take x minus 3y equals 2. And since y equals negative 2, I'm going to plug that in. X minus 3 times negative 2 equals 2. X plus 6 equals 2. X equals negative 4. So the solution to this system of equations in two variables is negative 4, negative 2. This is the one consistent, independent solution where these two lines intersect. This point is on both of the two lines. And that's how we solve using the elimination method. All right, so as I've mentioned, we have two methods that we would be expected to use on the test, either elimination or substitution. We did substitution in the video right before this. I don't care which method you use as long as you've got some algebra on your paper. As always, email me if you have any questions or concerns.